Hi friends, in this video we are going to discuss about characteristics of DC motor. The performance of a DC motor is best judged by characteristics. So first of all, these are the three characteristics. The first one is torque armature current characteristic, speed armature current characteristic and speed torque characteristic. These are the three characteristics of a DC motor. Okay, and coming to formulas related to characteristics. So already you know torque is proportional to phi Z Ia into P by A. So in this formula, when constants are neglected, we get torque equation. Torque is proportional to phi Ia. And coming to speed equation, N is proportional to EB by phi, where N is proportional to EB is equals to V minus Ia RA by phi for shunt motor and V minus Ia RA plus RAC by Ia for series motor. Okay, so now coming to shunt motor. So these are the characteristics for shunt motor. These three are shunt motor and these three are series motor characteristics and these three are compound motor characteristics. So let me discuss one after one. The first one is shunt motor characteristics. In shunt motor, torque is proportional to Ia. So why? Because phi is constant. So in this equation, when phi is constant, we get torque is proportional to Ia. So let me see the first characteristic curve, T versus Ia, torque versus armature current characteristic. So when load increase on the motor, armature current increases. When armature current increases, the torque also increases. So torque and armature current both are proportional to each other. That's why the curve is straight line. Okay, and coming to N by Ia characteristics for shunt motor. So N is proportional to EB. Phi is constant. Okay, so N is proportional to EB or N is proportional to V minus Ia RA. So here RA is very small. So the change in drop is also small. When load increases, armature current increases. When armature current increases, Ia RA drop also increases. But this drop is very small. That's why the drooping of speed is also small. So a small droop in the speed. Next, N by T characteristics. So remember, torque is proportional to Ia. So when torque is proportional to Ia, N by Ia characteristic is exactly equal to N by T characteristic. Okay, so the N by Ia characteristic and N by T characteristics both are same. Why? Because torque is proportional to Ia. Okay, and coming to series motor characteristics. In series motor, torque is proportional to Ia square. Actually, torque is proportional to phi Ia. So in series motor, phi is proportional to Ia. So that's why in series motor, torque is proportional to Ia into Ia square. Okay, so let me see torque versus armature current characteristic. So here, this is the point of saturation. Up to point of saturation, torque is proportional to Ia square. That's why the curve bend like this. And after saturation, the torque is proportional to Ia. So why? Because phi is constant. After saturation, flux is constant. That's why torque is proportional to Ia. And coming to speed versus armature current characteristic. So here speed is proportional to V minus Ia RA plus RSC. So in series motor we have two drops, IA RA drop and IA or ISC RSC drop. Okay, so the drop is V minus IA RA plus RSC. So here RA and RSC in series motor is very low. That's why this drop is neglected, and we are assuming the drop is constant. So at that time N is proportional to 1 by IA. N is proportional to 1 by IA. So let me see. When load increases on the motor, armature current increases. When armature current increases, so see this equation. When armature current increases, what happens in speed? The speed will decrease. Why? Because these two are inversely proportional. Okay? So when load increases, armature current increases. When armature current increases, the speed will decrease in series motor. And coming to N by T characteristic. In N by T characteristic, so torque is proportional to Ia square. When torque is proportional to Ia square, N is proportional to 1 by root T. So here when load increases, armature current increases. When armature current increases, torque also increases. When torque increases, automatically the speed will decrease. So when you see this equation, when torque increases, automatically the speed will decrease. Okay, coming to compound motor. So compound motors are two types now. So first one is cumulative compound motor, second one is differential compound motor. In cumulative compound motor, the total flux is equals to shunt field flux plus series field flux. Here flux strengthens each other. And coming to differential compound, the total flux is equals to shunt field flux minus series field flux. Here flux differs each other. Finally, in differential compound, flux weakens. In cumulative compound, flux strengthens. Okay, coming to characteristics. In compound characteristics, these characteristics are combination of shunt and series. Why? Because the compound motor is the combination of series and shunt fields. Okay, so that's why. So the characteristics, cumulative and differential characteristics are combination of series and shunt. So first of all, T by Ia characteristics of cumulative and differential. So when load increases, armature current increases. When armature current increases, the torque also increases in cumulative compound. Okay, and coming to differential, when load increases on the motor, armature current increases. When armature current increases, the torque will decrease. So like this. So this is the differential characteristic curve. Differential compound motors characteristic curve. Okay. Next, N by Ia characteristic. When you see the diagram, so that this is the shunt and this is the series. When load increases on the motor, the armature current increases. When armature current increases, in cumulative, the speed will decrease. In cumulative, the speed will decrease. And when load increases, armature current increases. When armature current increases, in differential, the speed will rise or the speed will increase. Okay, so this is the curve, differential curve, which increases. And coming to N by T characteristics, which are almost similar to N by Ia characteristics. Here also, when load increases, armature current increases. When armature current increases, torque increases. Why? Because torque and armature current both are in proportional. That's why when torque increases, the speed decreases in cumulative and speed rises in differential. In this way, we are going to discuss, or we are discussed, the the characteristics of DC motor. Okay, so in next video we will discuss about speed control of DC motor. Okay, bye.